Freeman Dyson's ideas about advanced civilizations constructing vast energy-harvesting structures around stars inspired not only science fiction but also real scientific efforts to search for signs of such astroengineering projects in the cosmos. Modern astronomical surveys have incorporated elements of Dyson's thought experiment into their search strategies, particularly in the field known as the search for extraterrestrial intelligence. This has led to studies that aim to detect the kind of telltale infrared signatures Dyson predicted, using increasingly sophisticated telescopes and data analysis techniques. The core idea Dyson proposed was that a civilization building a sphere or swarm to capture most or all of its star's light would necessarily have to dispose of the collected energy somehow. According to the laws of thermodynamics, this energy would eventually be re-emitted as heat, most likely as infrared radiation. From a great distance, such a star would appear dim or even invisible in visible light while shining brightly in the infrared portion of the spectrum. Modern surveys have tried to detect such anomalies by searching for stars or entire galaxies that radiate more heat than expected for their visible brightness. One of the earliest large-scale efforts inspired by Dyson's ideas was conducted by researchers using data from the Infrared Astronomical Satellite, which operated in the 1980s. Scientists examined data from tens of thousands of stars, looking for sources with unusual infrared emissions that could not easily be explained by natural astrophysical processes such as dust clouds or the aftermath of stellar birth and death. While these studies identified some objects with excess infrared radiation, natural explanations always fit the data more convincingly than artificial ones. In the modern era, surveys using more advanced instruments like the Wide-Field Infrared Survey Explorer have extended this work. Astronomers have scanned millions of stars and galaxies in search of the kind of infrared excess that could signal large-scale astroengineering. In 2015, for example, a group led by Jason Wright at Pennsylvania State University published a study that analyzed data on hundreds of thousands of galaxies, searching for cases where the infrared output suggested significant energy reprocessing by something other than stars or dust. The study found no definitive evidence of galaxies re-radiating energy in a way consistent with massive artificial structures like Dyson spheres. However, it did identify some candidates worthy of further study, where the source of the infrared emission is not entirely understood. In addition to looking at entire galaxies, astronomers have applied Dyson's logic to individual stars. One of the most famous cases that drew attention in recent years was the star known as KIC 84628522, often nicknamed Tabby's star or Boyajian's star. This star exhibited strange and irregular dimming patterns detected by the Kepler Space Telescope. Although the primary hypotheses for these dimming events focused on natural phenomena like clouds of dust or debris from shattered comets, the unusual nature of the light curve led some to speculate, at least initially, that it could be evidence of a partial Dyson swarm or other large artificial structures orbiting the star. Follow-up observations, particularly in the infrared, showed no excess waste heat, leading most scientists to favor natural explanations. Nonetheless, the case illustrated how Dyson's ideas continue to shape how we interpret strange astronomical phenomena and what we look for when searching for evidence of advanced technology. Modern searches inspired by Dyson's vision have also begun to consider more subtle and diverse signatures. For example, researchers have proposed looking for narrowband artificial laser emissions from stars that might serve as communication beacons. Others have considered the possibility of detecting unusual patterns of star dimming and brightening caused by megastructures transiting their stars, much like how exoplanets are discovered. Some astronomers have proposed looking for signs of thermal management on planetary or system scales, where an advanced civilization might be deliberately cooling its environment or moving waste heat into space in ways that could be detectable. Large astronomical surveys such as the Legacy Survey of Space and Time, set to be conducted by the Vera C. Rubin Observatory, may offer new opportunities to apply Dyson's ideas. The unprecedented depth and breadth of this survey will produce data on billions of stars and galaxies, enabling scientists to search for subtle anomalies in brightness, color, and variability that might hint at the presence of artificial structures or energy use on massive scales. The concept centers on the idea that a sufficiently advanced civilization, faced with ever-growing energy demands, would seek to harness the full energy output of its central star. Instead of relying solely on the limited solar energy reaching a single planet, this civilization might construct a vast assembly of structures orbiting the star, designed to capture and utilize almost all of its emitted radiation. This construct would likely not be a single solid shell but rather a swarm of independent satellites or habitats arranged in dense formation around the star. Each component would collect solar energy for the civilization's needs. Because the total energy output of the star would be intercepted, the visible light escaping the system would be greatly diminished. However, according to thermodynamic principles, the captured energy would eventually be emitted as waste heat, primarily in the form of infrared radiation. From an observational perspective, such a system would appear as an object emitting a high level of infrared radiation but significantly reduced visible light compared to a typical star. This led to the suggestion that astronomical surveys could search for these infrared excesses as potential indicators of advanced technological activity. The idea emerged as a thought experiment aimed at guiding the search for extraterrestrial intelligence by identifying unusual astrophysical signatures that could not be easily explained by natural processes. It has inspired numerous investigations to detect stars or galaxies exhibiting anomalous infrared emissions that might hint at large-scale artificial energy harvesting. Over time, the concept has been expanded and refined, giving rise to more complex models involving nested layers of energy-collecting shells, designed to maximize efficiency by channeling heat from inner layers outward. These multi-layered constructs resemble the nesting dolls of Russian tradition, symbolizing the layering approach. Such structures have been devised to function not only as energy collectors but also as vast computational platforms. In a study led by Jason Wright and his colleagues, the team sifted through an enormous dataset gathered by the Wide Field Infrared Survey Explorer, WISE, which had scanned the entire sky in the infrared spectrum. Infrared light is particularly useful for this kind of search because, according to thermodynamic principles, any large-scale energy consumption by an advanced civilization, such as capturing a star's output via megastructures, would eventually be emitted as waste heat in the form of infrared radiation. Among the hundreds of thousands of galaxies examined, most exhibited infrared emissions that could be explained by well-understood astrophysical phenomena. These include star formation regions, where clouds of dust heated by young stars glow brightly in the infrared, or the presence of active galactic nuclei, supermassive black holes at galaxy centers that emit radiation across the spectrum. However, Wright's team found a small number of galaxies whose mid-infrared output was significantly higher than expected given their visible light and other observable characteristics. These galaxies appeared to be reprocessing an extraordinary amount of energy, with their infrared brightness exceeding typical levels without clear signs of the usual sources like intense star formation or active nuclei. This anomaly raised the intriguing possibility that such infrared excesses could be the result of non-natural processes, specifically, large-scale artificial energy use and waste heat emission consistent with hypothetical megastructures or astroengineering projects on a galactic scale. In other words, these galaxies might be partially or wholly enshrouded by structures or systems capturing and re-emitting energy in ways that do not align with known natural astrophysics. Despite the excitement this suggested, the researchers were cautious. They emphasized that alternative natural explanations could still account for the observations. For instance, unusual dust properties, previously unrecognized astrophysical processes, or transient phenomena might produce similar infrared signatures. The data resolution and sensitivity also limited the ability to distinguish between these possibilities definitively.